This third example that we're going to go through to optimize is more general. It doesn't have any actual numbers, whereas like the first one, we had that farmer, we had 1.5 million square feet, actual number. The second one we had if 1,200 square centimeters of material, so on and so on. So we had actual numbers here. Now this third one is more geometric, okay? So it says find the dimensions of a rectangle of largest area that can be inscribed a circle of radius r. Okay? So let me draw you a picture of what we're talking about here. Okay, so you always want to draw a picture. So we're talking about a circle, right? Now it has some radius. I'm going to dot it. R, has some radius r, whatever that may be. We could give it a number here. We don't have to. And now what I'm going to do is I'm going to draw a rectangle inside of this circle. And what it means to be inscribed is when I draw it, I don't just draw a rectangle anywhere. What it means to be inscribed is that the corners of the rectangle are going to land somewhere on the circle to make that rectangle. So, put one right there, put one right there, down, over, come down. Alright, so as you can see, I've got this rectangle inside this circle here. Okay, so what we want to do is find the maximum area. Okay, now how I'm going to do this is I'm going to make a coordinate axis on this circle. Alright, and what it's going to do is I'm going to have this circle centered at the origin. Okay, here's going to be the origin. Let's see, let me do this in red. There's the y-axis. There's the x-axis. All right? So now if we have a circle, we know the equation of a circle. It's centered at the origin. Circle has the equation x squared plus y squared is equal to r squared. Okay? Now it usually has x minus x naught, y minus y naught, stuff like that. But x naught and y naught are the origin here. So it's 0, 0. Okay? So now let's look at the area formula for this rectangle. Now, if I go this direction from the origin all the way to over here, I don't know how far that goes out. We're being a little general here. We're not sticking actual numbers to things. But I go some distance x away. Okay? Now, since this is a rectangle, I know this distance, even though I'm going in the negative direction, this would be negative x if I was talking about the point negative x comma 0. But this would also be a distance of x. Okay, remember distances are positive. We're not talking about the coordinate here, where this would be at negative x0. We're talking about the distance from the origin, so that's x. So this entire side right here, I'll draw a small rectangle off to the side right there, just to represent that rectangle. We know it's 2x. The whole distance of this length right here is 2x. Now we could do the same thing for the y direction. We don't know how far this goes up. It goes up some just y distance. Let's just call it y. And also, this distance down here is also y. For the same reason that we talked about in the x. Yes, we're going in the negative y direction. If I were to put the point right here, this would be 0 comma negative y. However, I don't want the point, I just want the distance. I'm going down a distance of y, just like I went up a distance of y. So in total, this entire length over here, let me again put it on our little rectangle, would be y plus y, or 2y. So now we know what the lengths of the sides of the rectangle are. One side is 2y, the other side is 2x. So now we can get the area formula for our rectangle. So the area is equal to, well, length times width. Just multiply them together. 2 times 2 is 4. X times y is just xy. Okay, now we don't need the picture anymore. We don't need our little picture anymore. We have our equations that we need. And you're going to notice something that we have to do something that we did on the previous two problems as well. I want to maximize this area. Okay, since I want to have a maximum, that means I got to find the derivative, find the critical numbers, plug them in, so on, so on. But in order to do that, this has to be a function of x. Right now, x and y, just like the last two problems, we had to do something similar. We had to get rid of one of those variables in the function we're trying to minimize or maximize. Now we have another equation right here that we can go ahead and solve for y, okay? And then we're going to plug it in. So minus x squared, you get y squared is equal to r squared minus x squared. And now just square root both sides, square root. You get y is equal to plus or minus square root r squared minus x squared. Alright, so we do get a plus or minus here. However, we're not going to use the minus version. And here's why. This would tell me where the y coordinate is if I know the x coordinate. If you recall, we don't need the y coordinate. We don't need to know where it is. We just need to know the distance of it. So that's why we can ignore the negative version and only take the positive version, because the positive version is the same thing as the distance. Okay? And then we're gonna, take positive version, and then you're gonna come over here and plug it in. Okay? So, let's see. I'm gonna erase my arrow. You go over there, plug it in. I need some room. So the area now is gonna be a function of x. It's gonna be 4x, taking this, just the positive version, plugging it in, you get square root r squared minus x squared. Alright, so you may be wondering, hey, we have an r here. Isn't that another variable? It is not another variable, okay? The radius of a circle is constant. You may think it's a variable because we left it as a letter. However, if you were to actually do this problem concretely, you would have to specify a radius. Okay? So, we're just not specifying it. We're just not giving it a number. So this really is just a number. So then all of our, the only variable we have is x. So our area is really a function of x. Okay, we don't need any of this. We do need our area formula. I'm gonna rewrite it up here so I have more room. A of x is equal to 4x square root r squared minus x squared. Now, we have our area function. We know we need to take a derivative set equal to 0. But let's read the question one more time. Find the dimensions of the rectangle of the largest area that could be inscribed in a circle. Okay, so it wants us to find the dimensions, meaning we need to find, remember our old little rectangle, this was 2x, this was 2y. We need to find these numbers. So it means we need to find x, and we can plug it in here. That'll give us the dimension of the bottom. We need to find y, so that means I do need that equation, okay? That equation that we had for y. I'll write it up later. And then those would be my dimensions. So, take a derivative. A prime of x is equal to, that looks like a minus. There we go. I'm going to have to do a product rule. I've got one function times another function. Now, inside this function, I'm going to have a chain rule. Okay? So, derivative of the first function, derivative of 4x, is just 4 times the second function, square root r squared minus x squared, plus the first function, 4x, times the derivative of the second function, okay? Now, I'm going to erase the square root here, and I'm going to rewrite it as a 1/2 power. I think it's a little easier to see that way. So it's a power rule. Bring the 1/2 out front. Rewrite it, x, or r squared minus x squared. Subtract 1 power from the 1/2. 1/2 minus 1 is negative 1/2. Now, times by the derivative of the inside. Now, we already said that the radius is a number. Okay, so this is a constant. The derivative of constant is 0. Now that right there, that's a variable, so we can take derivative of this. This is our inside right here, and it's just another power rule. 2 times negative 1 is negative 2, so multiply by negative 2, drop 1 power, x. Alright, so some things cancel. Let's see. This right here, this, I can cross that off with that 2 right there. That's the only thing that really cancels. Let's clean it up a bit. So, 4 square root r squared minus x squared plus 4 x times x is x squared. This has a minus, so this plus should actually be a minus. I missed that. And then we have this piece right there. Now, I'm going to write it on the denominator. Divided by, it has a negative exponent. That's why it's going on the denominator. R squared minus x squared to the 1/2 power. Okay, so what I'm going to do is I'm going to find a least common denominator. Remember what our overall goal. We want to set this thing equal to 0 so we can solve. Now, I can set it equal to 0 now and do it. That'd work. But let me go ahead and find a least common denominator. So if you notice, this is the only denominator. Therefore, this has to be the least common denominator. Equals, big division, r squared minus x squared to the 1/2 power. Now, since this piece already has the least common denominator, I do not have to multiply that numerator by anything. So over here, I'm going to write a minus 4x squared. Now, look at right here. This is like being over 1. It doesn't have anything this least common denominator has. So what I have to do is I got to take this and I got to multiply it over here. So if you recall that this right here, we did it up here, we changed it to a 1/2 power. Now if this and this are the same exact thing with a 1/2 power. If you remember your exponent rules, multiplying two things with the same base with exponents, you just add the exponents. 1/2 plus 1/2 is 1. So it's this entire thing to the first power. So I could write it like this. 4 times r squared minus x squared. Okay? Now, here's our derivative. It's simplified. So what I'm going to do is I'm going to erase all this and just rewrite our result back up here for our area formula. Now, one thing before I do that, let's simplify the top a little bit. If I distribute this 4, you get 4r squared minus 4x squared. If you look, negative 4x squared, another 4x squared, those are like terms. You could put them together and get negative 8x squared. So that's what I'm going to write up here. So we've got this 4r squared minus 8x squared divided by the denominator. R squared minus x squared to the 1/2 power. Oh, I wrote that where a of x was. My apologies. 4r squared minus 8x this was 4x times, okay. There we go. So, now what we want to do is we've got the derivative, we want to find when the area is a maximum. Since we're talking about minimums and maximums, we need to find the critical numbers. Meaning we need to set the derivative equal to 0. So I'm just going to put it equals 0 right there. And now since we have a rational function, the only way a rational function can be 0 is if the numerator is 0. So, let's set the numerator equal to 0. 4r squared minus 8x squared is equal to 0. And it's a really easy equation to solve for x. So plus 8x squared plus 8x squared. You get 4r squared is equal to 8x squared. We're solving for x here. The r is just a number. It's a constant. So I'm going to divide by 8. And now that's 1/2 r squared is equal to x squared. And then it's just a square root. So square root this side, square root this side. Now square root of 1/2 is root 2 over 2. Times r is equal to x. So now we have our x coordinate. So we don't need any of this now. We've got one dimension. Oh, we got to multiply it by 2, but we've got one dimension. So let's go ahead and find the other dimension. So let's see. We actually don't need this. X is equal to root 2 over 2 r. Now,